This video is a complement to the previous video. Each laboratory has been equipped with individual safety equipment and laboratory safety. This laboratory equipped with fire extinguisher, aid box, and individual safety equipment such as lab coats, goggles, and gloves. This laboratory have emergency shower and eye wash as well for laboratory safety in emergency situation. Besides simple practicum, students also do practicum using advanced instruments such as HPLC, UV-visible, TLC, conductometer, flame photometer, turbidimeter, refractometer, mercury analyzer, and other instruments. In conductometry experiments, students are expected to be skilled in using a conductometer to determine the electrical conductivity of a solution that is acidic or basic, including water quality testing. In addition, students are also expected to be skilled in titration using a conductometer titration tool. This experiment supports analytical chemistry, instrumental chemistry, environmental chemistry, and advanced chemistry courses. In this experiment, students are expected to know techniques for analyzing the alkali and earth-alkali metals. In this experiment, the students are trained to use the flame photometer to determine the sodium and potassium concentration in commercial drinks and environmental samples. In addition, students are also expected to know the necessity of establishing calibration standard curves. These experiments support instrumental chemistry, analytical chemistry, inorganic chemistry, and environmental chemistry courses. In this experiment, students are expected to be skilled at using a turbidimeter and determining the level of turbidity of a liquid sample. These experiments support courses in analytical chemistry, biochemistry, and environmental chemistry. Students are expected to know how to apply the spectrometry method to determine the concentration of an analyte. In this experiment, students are trained to use the UV-VIS spectrophotometer. They need to know how to prepare sample, to make standard solution, determine the maximum wavelength to be used in determining analyte, create the calibration curves, and then use the curve equation to determine the analyte concentrations from the sample. These experiments support courses in analytical chemistry, biochemistry, organic chemistry, inorganic chemistry, instrumental chemistry, food chemistry, and food analytical chemistry. In refractometry experiment, students are expected to be skilled in using a refractometer to analyze organic compounds qualitatively by determining the refractive index of a compound. This experiment supports courses in organic chemistry, food analysis chemistry, food chemistry, instrumental chemistry, and etc. The weighing activity aims to improve students' skill in using analytical balances correctly and thoroughly, which is carried out in each experiment. Thin layer chromatography, TLC experiment is one of the experimental units of analytical chemistry and organic chemistry practicum. The aim is that students have skills in separating organic and inorganic compounds. The procedure in this experiment are sample weighing, extraction, evaporation, and finally the TLC test. This practicum supports courses in analytical chemistry, biochemistry, and organic chemistry. In this experiment, students are expected to be skilled in preparing samples for analysis of mercury level. First, students dissolve the sample using strong acid in a fume hood. Then, use the mercury analysis tool and read the results. This experiment supports courses in instrumental chemistry, food analytical chemistry, organic chemistry, and inorganic chemistry. In this experiment, students are expected to be skilled in conducting sample preparation and using HPLC instruments to measure qualitatively and quantitatively the compound content of a sample based on differences in the polarity of the compounds in the sample. These experiments support courses in organic chemistry, biochemistry, food analysis chemistry, and environmental chemistry.